Good morning. Today's lesson, we are continuing with the absolute value. Today it's going to be 13 3B lesson, and we are going to continue to solve absolute value equations. So the first thing is we're going to explore and learn few new vocabulary words. So absolute value equation differs from linear equations in that linear equation will have one solution versus the absolute value equation will have sometimes two solutions. And that is indicated with a disjunction, a mathematical statement created by connecting two other statements with the word or. To see why there can be two solutions, you can solve an absolute value equations using graphs. So the first thing we are going to do is they want us to plot the function f of x equals 2 absolute value of x minus 5 minus 4 on the grid. They want us to solve the function and then plot the function of g of x. So when you're given the equation, the way you solve it, you break it into two separate equations. So this is going to be your y2 equals to 2 and y1 equals to whatever the first half is. So that's how we got f of x equals 2 absolute value of x minus 5 minus 4. And then we'll plot the second equation that is equal to 2. So the way we are going to do this, we are going to plug it into the table. So the first one we are going to do is the y1. So y1 equals to 2 absolute value of x minus 5 minus 4. And I'm going to make a good old-fashioned table. So it's going to be x, and then we're going to calculate y. So I'm going to just choose random numbers of, of x, and I'm just going to start with 0, 1, 2, 3, 4, 5, and 6. And let's see what happens with these numbers. So if I plug in 0 for x, I would have the absolute value. So I would have 2 absolute value. 0 minus 5 is just negative 5 minus 4. Well, you learned that absolute value of negative 5 is just going to be always positive number, so it's just going to be positive 5. So 2 times 5 is 10, minus 4 is positive 6. So my first point is 0, 6. The second one is going to be same, except I'm going to plug in 1. So it's going to be 1 minus 5 minus 4. So 1 minus 5 is negative 4. Absolute value is positive 4. 4 times 2 is 8. Minus 4 is positive 4. So 1, 4. Then we do the same thing with 2. 2 minus 5 minus 4. So 2 minus 5 in absolute value is negative 3. Absolute value is positive 3 times 2 is 6. Minus 4 is 2. So 2, 2. Next one, 2 times absolute value of 3 minus 5 minus 4. So 3 minus 5 is negative 2. Absolute value is 2. 2 times 2 is 4. 4 minus 4 is 0. So that's 3, 0. 2 absolute value of 4 minus 5 minus 4. So 4 minus 5 is negative 1. Absolute value of negative 1 is 1. 1 times 2 is 2. Minus 4 is negative 2. And let's go with 5. So 2 absolute value of 5 minus 5 minus 4. Well, 5 minus 5 is 0. Times 2 is 0. Minus 4 is minus 4. So you will have 5 and negative 4. And last one is 6. So 2, 6 minus 5 minus 4. 1, 2 minus it's negative 2. So it's 6, negative 2. So let's go ahead and now plot our numbers. So 0, 6 is my first point. 1, notice that my my scale goes by 2, so this is going to be 1, so 1 is halfway, so 1, 4, 2, 2, 3, 0, so my 3 is right here, so it's going to be between 4, negative 2, 5, negative 4, 6, negative 2. So notice that's starting to repeat. So the unique feature of absolute value, the graph of an absolute value looks like a V. And so it goes into infinity this direction and goes into infinity this direction. So absolute value graph is always going to look like a V. Okay. Now, the second equation I have to graph is y is equal to 2. So y is equal to 2 is upside down h. Remember, I taught you that before, you learned that before, it's horizontal line. So 2 on y is here, and my horizontal line is here. So if you are asked how many solutions does this equation have, you would answer how many places does my line cross my V graph, and notice that it crosses in 2 places, so this would be 2 solutions. So what would be the solution? The first solution would be x is equal to 2, and the second solution, x is equal to 8. 2 solutions. X is 2 and x is 8. So absolute value is a V graph, and we have situations when you have 2 solutions. So this is my graph where I have 2 solutions. We might have 1 solution. So the graph, if I have 1 solution, would look something like this. Let's say this is my graph for the line I'm looking for, and my V is right above. So in this case, I would have only 1 solution because it crosses only in 1 place, or I would have no solution when they do not cross at all. Okay, they do not cross, and it would be no solution. Why might you expect most absolute value equations to have 2 solutions? Why not 3 or 4? Because the absolute value represents distance from 0. And you have a number line has positive numbers and negative numbers. So if you're looking at the x-axis, I'm looking at the numbers. This is my 0. I have numbers in positive direction, numbers in the negative direction. And so when I open the floodgates, my castle gates, I'm going to write 2 equations, and one equation has a negative solution and the other equation has a positive solution, because remember, my absolute value represents the distance from 0. Okay. Next question, is it possible for an absolute value equation to have no solution, 1 solution? If so, what would each look like graphically? Okay, so so it would be, if you absolute value cannot be negative, cannot have negative distance. So in this case, you have no solution. So no solution means that my v, if this is my x-axis, my v would never cross the x. So if I have this situation, it doesn't touch the x-axis. I can have this situation where it doesn't cross the x-axis. This would be another one. It doesn't cross, right? It hovers above, but there's no solution because it does not cross x-axis. If I have, this is no solution. And to have one solution, if I'm looking for x-axis, one solution would be if it touches in one place, touches in one place, touches in one place. This is one solution. And of course, two solutions is if my line crosses in two places. That would be, if it crosses in two places, that would be two solutions. Okay? So let's go to the next one. And so we are going to now go back to solving, continue solving the absolute values using algebra. And to solve the absolute value equations algebraically, you will always want to first isolate the absolute value expression. So isolate the absolute value. And then use the rules that when you open the gates, you have a positive or negative. We use of this junction here in the rule for values of x. You cannot know from the original equation whether the expression inside the absolute value bars is positive or negative. So you must work through both possibilities. So you have to isolate the absolute value. You have to solve each one because you don't know which direction it's going to the answer be. So here we want to solve each absolute value equation algebraically, and we want to graph the answer on the number line. So the first thing is, this is continuation of yesterday's lesson. Notice that my castle, my absolute value is not by itself. So first thing we're going to subtract 2 from both sides. Now I have absolute value by itself. It's equal to 6. I'm going to open the gates because my castle is now by itself, and I'm going to have two equations. First equation is going to be 3x equals to positive 6, and the second equation is going to be 3x equals negative 6. So solve for x, so x is positive 2, and x is negative 2. So my two solutions is positive and negative 2, and you just put the dots on the number line. Let's look at the next example. In the next example, again, my absolute value is not by itself, so I'm just going to isolate them first. And remember, the first thing you need to get rid of the number that's away from my castle, so you're going to add 2 to both sides. So it's 3 times absolute value, 4x minus 5 equals 19, and 2 is 21. And so remember, everything inside the castle is protected. You do not do anything with those numbers until you have the castle by itself. So now I'm going to divide by 3 both sides. So I have 4x minus 5 equals to 7. And now that I have my castle by itself, I open the gates. So the first one is 4x minus 5 is equal to positive 7. And the second one is going to be 4x minus 5 is equal to negative 7. You have to write both equations, and you have to solve both equations. So I add 5 to both sides. I have 4x equals to 12. So 4x equals 12. I divide by 4. x is equal to 3. That's my first solution. And then I need to find my second solution, which is -2, and then I divide by 4, and I get x is equal to -1/2 because I have to simplify. So +3, I bubble that, and -1/2, so -1/2 is here. Those are my two solutions, and I bubble those in on the number line. Okay, next example. Absolute value is not by itself, so I'm going to highlight this. I know that everything inside is protected, so that's going to stay exactly where it is. So I'm going to -5 to both sides. So I have -2 absolute value of 3x minus 6 equals to -4. And now I need to get rid of the -2. I know this is multiplication, so opposite is a division. And I'm noticing that I have a negative and negative, which is going to turn into a +2. So now you have two equations. The first one's going to be 3x minus 6 equals to +2. And the second equation is 3x minus 6 equals -2. So adding 6 to both sides, you have 3x equals 8. And then I'm going to divide by 3, so x equals to 8 over 3. So 8 divided by 3, you can change it into decimal if it's easier for you, or you can go, that's 2 2/3. Okay, so that would be your answer. Okay, so I need to solve this one, and I didn't give myself much room, so I'm going to continue here. So it's going to be 3x minus 6 equals -2. I'm going to add 6 to both sides. So 3x equals to +4. Divide by 3, x is 4 over 3, and that is 4 over 3 is 1 1/3. So if you look at the number line, okay, the number line, each one represents, so 2/3. So it goes by 2/3. So if I have 4/3, right? So my positive 4/3 would be here. And my 8/3 would be, so 2/3, 4, no, that's not right. 2/3, 4/3. Oh, 2 2/3, sorry. So 2 2/3 would be on this side. So this would be my number. Okay. So let's look at the next one. And so the next one is, let's see, 1/2 x plus 2 equals 10. And so this is an absolute value. And so the first thing is you need to notice that this is protected. And so we're just going to multiply by 2 both sides. And so you are going to have 2 1/2 cancels. So now I have just x plus 2 inside the castle equals to 20. And my castle is by itself. I can lower the gates. So x plus 2 is 20. Oh my goodness, what am I doing? X plus 2 equals 20. And the second equation is x plus 2 equals -20. So -2 on both sides, x equals to 18. And x equals -22. So -22, my numbers go by 4. So this is 20 negative 20, negative 22 is halfway, and um, 18, so 4, 8, 16, 20, so 18 is between. So these are my two solutions. Okay, let's go to the next page and see what we have there. So here we are asked to, you have seen that absolute value equations have two solutions when the isolated absolute value expression is equal to positive number. When the absolute value is equal to 0, there is a single solution because 0 is its own positive. When the absolute value expression is equal to negative number, there is no solution because absolute value is never negative. So basically, here are the rules that we have been applying through yesterday's and today's lesson. So we want to isolate the absolute value, okay, first, in each equation to determine if the equation can be solved. If so, they want us to finish the solution, finish the problem. If not, write no solution. So in this example, that tells you the step, what you need to do. So the first thing they tell us, we're going to subtract 2 from both sides. So negative 5, absolute value, x plus 1 plus 2 equals 212. So the first thing I'm going to do is I'm going to subtract 2 from both sides. So negative 5, x plus 1 equals 10. And then you're dividing both sides by negative 5. So x plus 1 equals negative 2. And you can say no solution because absolute value is never negative. Okay, that's no solution. Okay, let's look at the next example. And in the next example, the first thing we're going to do is we notice that my absolute value is not by itself. I'm going to add 3 to both sides. So now you have 3 over 5, 2x minus 4 equals to 0. So the next thing I'm doing is I have a fraction 3/5. To get rid of the 3/5, you are going to multiply by reciprocal. So you're going to multiply by 5 over 3. The reason you do that, because look what happens now. My 3's cancel and my 5's cancel. So you're going to multiply also this side by 5 over 3. Well, this is easy because 0 times any number is 0. So now you end up with 2x minus 4 equals to 0. Well, you cannot have a positive or negative 0, so you're just going to have 0. And when you open the gates, you're just going to have 2x minus 4 is equal to 0. Solve for x, because you're only going to have one solution. So 2x equals to 4, divide by 2, x is equal to 2. So one solution, and that's x is equal to 2. Okay, isolate the absolute value expression and solve. So see if you can do these two problems on your own. So go ahead and pause if you would like this lesson. Do this on your own and then see if we match. If you feel like you're struggling and you need more help, I will do it here for you and you can do it step by step with me. So the first thing is, I notice that absolute value is not by itself. I need to isolate it, so I'm going to subtract 7 from both sides. So 3 times 1/2 x plus 5 equals to negative 2. And next thing I need to do is I need to divide by 3. And right away, I hope you notice something. What kind of answer do you have? Negative. So I don't have to solve anything else. I can right away say no solution. So this, let it be a lesson to you. Sometimes this problem looks kind of difficult because it has a fraction and you're like, oh my goodness, what am I going to do? But once you started, it ended up being super easy problem, not much to do because you have a negative solution. Okay, Let's look at the next one. Again, my absolute value, it's not by itself, so I need to get rid of the negative 7, positive 7 first by subtracting. And so I have 9 times 4 over 3x minus 2 equals to 0. And now I divide by 9 both sides, and you know that 0 divided by any number is 0. So now you're going to have an absolute value of 4 over 3x minus 2 equals to 0. So I already know this is going to be one solution, because 0 cannot be positive or negative number, and basically I just go 4 over 3x minus 2 equals to 0. So to solve for x, you're going to add 2 to both sides. And now I need to get rid of the 4/3. So remember what I said earlier. Hopefully you remember that you can multiply by a reciprocal. So you're going to multiply by 3 over 4. 3 over 4. So my 3's cancel, my 4 cancels. And here I'm going to put 2 over 1. So those of you who are having trouble with fractions, go ahead and multiply. So 2 times 3 is 6 over 4. And now you can reduce, so you can divide by 2 both of them. So x is equal to 3 over 2. Or those of you who want to reduce, you reduce 2 and 4, and you get 3 over 2 right away as an answer. Okay? Good. Okay, so let's go to, hopefully, those of you who did it on your own, you were able to do this, and you got the same answer. The last thing we're going to do is we're going to discuss the different scenarios. It says, why is it important to solve both equations in the disjunction arising from an absolute value equation? Why not just pick one and solve it, knowing the solution for the variable will work when plugged back into the equation? So we always have to simplify first. And isolate absolute value, okay? We must write two equations and solve each. Okay, because you never know if you're going to have one solution, two solutions, no solution. So you always have to isolate it, set it up, lower the gates, and solve. The next scenario, it says, discuss how the range of the absolute value function differs from the range of the linear function. Graphically, how does this explain why a linear equation has exactly one solution, while an absolute value equation can have one, two, or no solutions? So if we look at, I think the easiest thing is to graph the equation. So we have linear, and remember the linear is just a line. So if I have some equation, let's say this is my linear equation, okay? And remember your domain is x, and range is your y. So if I'm looking at my linear equation, each point on this line has only one x as a solution, right? Each one has only one x. So domain is your x. Because this goes into infinity on both ends, my domain are all real numbers. Okay, all real numbers. There's no limit. This goes into infinity and positive, into negative, so all real numbers. At the same time, if you look at y, which is your range, because this goes into infinity, this goes into infinity, all real numbers is my range as well. So all numbers are my possibilities for y, and all numbers are my possibilities for x. Now, absolute value value graph is a V. So if I have some graph that's like this, and let's say I have my graph goes like this, my absolute value, and this goes into infinity, this goes into infinity. My domain, in this case, and range, let's see how they change. So x, in this case, I can choose any number for x. It goes into positive. So all real numbers is my domain. Now your range is your y. Remember, your range is y. Notice that in this case, my y, can my y be negative numbers? No, my y goes into the positive direction, and the smallest is it's 0. So in this case, my range would be all the numbers that are greater or equal to y, to 0. What if I had, and I'll do this one in red. Let's say this is -4. And what if I had an absolute value that goes like this? And so again, and I'll do my domain and range in red. So domain is all the x's, right? All real numbers. So all real numbers is my domain. Now your range has changed. Your range has to be numbers that are greater or equal to what number? It cannot be lower than -4. So y is greater or equal to -4. Okay, my range are all the numbers that go into this direction. So it can be bigger than -4, but they can never be lower than -4. And the last thing, we are going to describe the steps again. So the first thing is to describe in your own words the basic steps to solve absolute value equation. So the first thing is we always want to, so if I have the equation 2x minus 4 plus 5 equals to 12, I'm going to go over the steps. So the first step is subtract 5. Then the second step is divide by 2. So I'm going to do this on the side here. So minus 5. We have 2x minus 4 equals to 7. Then you divide by 2. Then you get absolute value alone. So I have x minus 4 equals to, oh, I didn't choose good numbers, 7/2. Sorry about that. Get absolute value alone, and then the next thing is you can open gates, and first one has to be positive, and second one has to be negative. So you're going to have x minus 4 equals 7/2, and x minus 4 equals -7/2, and solve. So these would be the steps for you to solve the absolute value. Okay? Hopefully you got this lesson. This is a repeat of yesterday's lesson, so not much new. If you need to look at it again, go ahead and review again.